Good afternoon, everybody. How's it going? I'm Nathan Tabor. Thank you so much, Sai, for the lovely introduction. Kicking off the second half of Container Day here at KubeCon. Really appreciate everybody coming back for the second half. I know we had a whole bunch of morning sessions. Hopefully a few of you got to catch those. I'm going to be talking a little bit about our philosophy around Kubernetes and EKS that we have here at Amazon, and also a little bit about our roadmap. I'm going to share kind of a mix of some things that we've shipped and some things that we're working on. I'll try to tell you which is which, but I'll also keep you guessing a little bit. So let's jump into it. I really love this quote. This is I didn't put who this is from. This is actually a Jeff Bezos quote. And really, it's that one of the biggest pieces of philosophy at Amazon is that we work backwards from customers, and that we wake up every morning thinking about, I guess being terrified is one way to approach it. I don't know if I'm terrified, but I really think hard, and I know the team does as well, about what do our customers want. Our customers are divinely unsatisfied, and we really start everything thinking about how much of an obligation do we owe our customers. And really the better way to put this is we see ourselves as sometimes the host of a party, and our customers are invited guests to that party. And how can we make them productive? How can we make them comfortable? How can we make them successful? So I want to spend a few minutes before we get into specifically what we're doing with EKS, talking about our philosophy to how we actually build product at Amazon, and how do we get any of this stuff, and the whole idea that is working backwards. Because it's kind of like normal now for a lot of product teams to operate this way, but I think that we do it a little bit differently at Amazon still. And we have a very unique approach. So what does it actually mean to work backwards? So first, it means that we start with what customers tell us. And that's always where we begin. It's not necessarily where we end, because what we're trying to figure out is not just what our customers asking for, but what do they need? And if you've ever had a small child, I have a small child now, you'll realize that what they ask for and what they need might be two very different things. So even if you give someone what they ask for, they may be unsatisfied very quickly. So we think about what are our customers asking for, what are they telling us, and then what is that final thing? We envision that final experience. How should it be? And maybe it's going to take us a long time to get there. And I would say this is probably the most defining part about working backwards at Amazon, that even if this is several years away or longer, then we're thinking about what is that final vision. So what we can build quickly is a consideration, but it's not the only consideration. It's not the most important thing. It's important to ship, but it's also important to iterate. And we're very comfortable getting it wrong and iterating over time to get the right answer. I'm going to talk a little bit about some of the, I'll bring this back up again later. There's a project that we've recently done where we had a hard iteration, and now it's a great project, but the first time that we launched it, it wasn't so great and nobody liked it. You don't know that because no one knew about it because no one liked it. So we're comfortable with things being wrong. We're comfortable with being misunderstood for a while. And this all works because we get direct customer feedback, and we live off of customer feedback. I think customer feedback is oxygen for our team. So examples, what is working backwards? All of this stuff, like pretty much anything you see at Amazon, like some customer has told somebody you need to build this at some point. AWS, EKS, EKS Anywhere, Carpenter, pretty much everything at AWS that we've ever done, some customer somewhere has said, I really, really, really need that. I need this capability, and that's why we built it. So one thing that's really interesting about being at KubeCon and being in a place where open source and people are collaborating on products and technologies, not just waiting for companies to build them and ship them, is that we believe that open source and working backwards are actually very, very compatible things. These are not incompatible things. They work very well together. And that using open source, we can get a lot more feedback and a lot more customer data that helps us contribute and helps us be a part of the community. And so one of the ways that's really obvious to do this is our open source public roadmap. If you haven't heard about it, now you have. We have a public roadmap that's out on GitHub. Many of the things I'm going to talk about today are actually on this public roadmap. You can go and find them. If you are looking at the public roadmap, or you're using EKS or some other AWS product that's a Kubernetes product, and you say to yourself, wow, this thing really would be better if they did X, open an issue for us. Tell us. You'll find some really active discussion threads, and we've been really tickled. Since we launched this a few years ago, we've seen a number of other companies and other teams at Amazon do this, and I think that that's a really cool thing. So even though we're AWS, we want customer feedback, we want information. I'm going to talk a little bit about what we're actually doing with this feedback and what we're building in a second here. But I will put out a shout out. There's a lot of Amazon employees here at KubeCon. They're in this room. They're standing around the edges. They're watching this talk. I see some of you. I won't name names. They're also going to be at our booth later, and you're going to see them in the hallways. If you think that we could be doing something better, if you think that we should be building something at AWS for Kubernetes, or we should be involved in some project, just grab them by the sleeve, grab me, and tell me. I may not be able to do anything about it right away, but just knowing that, having that information is really, really great. So don't be afraid to come up. Don't be afraid to talk to us. Stop by the booth. Tell us what you think would make your lives a lot better. We want to hear it. So we're listening to all these customers. What do they actually want? What do we hear from them, right? So there's 4 things that we're hearing a lot of our customers ask for these days when it comes to Kubernetes. The first is standardizing IT operations to accelerate change management that accelerates delivery. The philosophy behind this is if you can make lots of changes very quickly, you can actually do things a lot faster. You can iterate quickly. That sounds familiar. We just talked about that a few slides ago as like actually something that's Amazon's product philosophy as well, right? Like not a weird thing at all. If you can make changes quickly, if you can make changes safely, then you can innovate. So our customers want this too, and they see Kubernetes as the way to do it. Like, why should I even adopt microservices? Why should I even waste my time with something like Kubernetes? It's an operational framework to make changes quickly across your organization and standardize how you make those changes. So that's the first thing. Second thing, and this is really important these days, is reducing fixed expense. They want to eliminate contracts, eliminate management overhead. They want to enable their entire company, not just a single dev team. They want to actually enable the whole company to move together and move a lot faster. So that if somebody has an innovation, they can roll that out to everybody and they're not siloed in terms of how they do their IT. And then obviously reducing risk and planning for the future is huge. Lots of companies we talk to, these are very big companies and small companies who watch the big companies. They see companies get locked into large, complex, proprietary frameworks, things that take millions of dollars of consulting hours and developer time to implement, only to see that kind of wither on the vine 5 years later or 3 years later. And then they're sitting there going, oh my gosh, what do we do? So Kubernetes, for a lot of our customers, is a way to future-proof. They know that, okay, this is great. We have lots of vendors. We have a robust ecosystem of people that are supporting this today, but it's also open source in the way that it's governed, in that in 3 years, if 5 years, if all these people divest and they go on to do different things, or all these companies fall apart, we at least can take some of that over. There's still going to be a community here, right? So it's a long-term investment for them. And we're here to support our customers in the long term. I can think of very few things that AWS has ever actually turned off. So when we make an investment like EKS, when we make an investment like we have into Kubernetes, we're here to do that for a long time into the future. Okay. Besides the future, the best way to predict the future is to look at the past. So I want to just like take everybody on a really quick trip back in time and look at what have we actually done. What's our report card look like? What's our year in review? So EKS went GA in 2018, June 6th, 2018, 3 days after my birthday. And it was a really big moment for us. We didn't have a lot of customers. It's been a long time since then. And we've had 3 main themes of development. We'll probably have a 4th theme at some point in the future here, but so far we've had 3 main themes of development. First, we started with the control plane. Just give us a managed EKS or Kubernetes cluster. Do that for us. We literally did nothing else. I think when we launched EKS, we didn't even have upgrades. You couldn't upgrade a version. So we had that control plane. And then as we got the things sorted out, like, oh, now I can upgrade versions, very cool. Customers started to say, okay, that's really great, but what about all the nodes? What about all the compute? What about all the data planes? We said, oh, we should probably build something there to help customers. So Fargate and managed node groups came along, and we continued to innovate there. And then that was our data plane. That was our 2nd theme. We started that in mid-2019. And then we're going along, we're saying, this is great environment. And customers said, yeah, but there's so much else I need to do. There's so much else I need to manage. I need to upgrade all this software. Can you help us with the cluster operation? So that's been our latest theme. We've been working on this since the beginning of 2021 with innovations like Addons. And we've been expanding to new environments with new products like EKS Anywhere and EKS on Outposts. And there's lots of different innovations that are related to this cluster operations theme that are going on in those products as well. And this is our latest theme, cluster operations. I'm going to talk a little bit about this as well. And that's what we're working on right now. And then I won't I mean, this is just like all awesome stuff. I mean, I could spend the next 50 minutes talking through all the cool things that we've done here and things that we've brought to people. But let me talk to you about what we're doing and what's coming up next. So what are we working on? We're working across 5 main investment areas for EKS right now. And this isn't just EKS, this is EKS, EKS Anywhere. We see ourselves as Kubernetes from AWS or Kubernetes at AWS. So a lot of different products that are happening. So the first thing is, how do we centralize and simplify our cluster management? How do we actually make it easy to start and manage one or many Kubernetes clusters? The second thing is, okay, I can start those clusters, but are they ready to go? Can I put an app on them? Can I put a batch processing job on them? Are they application ready? So this is the second thing we're doing. And this is kind of, how do I get all the right supporting software and tooling and the right configurations and the right templates? How do I get that all ready to go? So application ready clusters is what we call it. And then the third thing, this is becoming more and more important, especially as customers start to mature Kubernetes throughout their organizations and they get calls from their chief financial officers saying, how much are you spending on those Kubernetes workloads? Why can't I see all the visibility I used to have with VMs? So cost, visibility, and efficiency, incredibly important. It's something we're investing a lot in these days. We have some great partnerships there as well. Finally, this is more specific to running on AWS when using EKS, but access to those AWS capabilities. We believe one of the biggest reasons, as awesome as all the other stuff we do, the biggest reason why you would run Kubernetes on AWS, or one of the top reasons, is to get access to all the stuff that AWS has to offer. We have a bunch of really cool infrastructure services. We have a bunch of really cool higher level services. I'll talk about a few of those. Getting access to that stuff's important. And then finally, we want to let you deploy in any environment. Lots of our customers are born in the cloud, built in the cloud, cloud native. But lots of our customers still have things that are going to live on premises for a long period of time. We have customers who need to put very latency sensitive applications in co-location facilities. We have industries like telecommunications where they need stuff in the cloud, in the data center, at the edge. And our goal is to bring, if we're going to bring Kubernetes to be an organizational standard and support customers, we need to support all those different environments from the cloud into the data center and out to the edge. So that's another place where we're working. So I'm waxing on, so I'll have to move quickly here. So the first thing is that cluster management. What are we doing? We're establishing EKS as a hub for Kubernetes operations in the cloud. So what does this mean? It means you can get multi-cluster visibility. You can connect any cluster back to EKS right now. We have a really cool product called EKS Connector. It's a subtle product. You won't see it, but it's there if you look in the documentation. You can connect any conformant Kubernetes cluster back to AWS. You can visualize the entire API. We've been adding in a bunch of charts and metrics and graphs, and we have some cool stuff about an eventing system that we're working on, and you can visualize it all right there. And any, EKS on AWS clusters are automatic. We have on-premises clusters, EKS Anywhere. Self-managed on EC2 also works. Managed clusters from other cloud providers, sure. As long as it's Kubernetes, you can connect it back. And our goal is to give you that single pane of glass across all your clusters. So what's coming up there? Performance and status dashboards, I mentioned that a second ago. Doing more centralized cluster lifecycle management on an environmental basis. Integrating the CLI and giving you object management with GitOps directly in the console is something that we're starting to design that right now. And then also bringing Addons support to those connected clusters. So right now we'll talk about EKS Addons. They support EKS clusters. We have a really cool system on EKS Anywhere called, I'm forgetting the name, Lichun, right now. But curated packages. And we're going to bring that Addon support to connected clusters as well. What does that look like? It looks like this. It's really cool. You just see the different clusters. There's an EKS Anywhere cluster and a GKE cluster, and it all shows up in your console. Sweet. There's the, in case you didn't see it, there's the box. So then in EKS, it's not, seeing all your stuff is really cool. You also want to simplify updates. So updates are a big deal in Kubernetes. We still have 3 version releases per year that you have to think about as a customer. So already today we've made our updates a lot faster. We've more than halved the time it takes to do an update to under 10 minutes on average. So huge improvement. I think it was 25 minutes before. We're bringing unified APIs together so that you can manage cluster, nodes, add-ons. We're working on what we call pre-flight checks, where we can give you the idea, like, if I press the button to update this cluster, what's going to fail? Am I using any APIs that are going to be deprovisioned or not work anymore? Is something going to break on the cluster? Can we give you an idea of that ahead of time? And also single-click actions where you don't have to actually upgrade any of these things individually. You can just say, bring this cluster to the next version, and we'll bring the whole cluster to the next version. Security, also really important. Barry talked about this morning. Security, we see it as job 0 for AWS. So there's security of AWS. There's also security of your cluster. We have a bunch of different security tooling and layers where things come together. I think if we haven't talked about that already today, we will be. The first thing that we're working on is a feature that we call IAM access control. This will be coming out in the next year here. And this is actually moving all the IAM role mappings from Kubernetes, all that IAM to RBAC mapping into the EKS API. So you can use the API, you can use the console, you can set up all your permissions on the cluster. We're also improving the URSA, which is IAM roles for service accounts. So this is how do my pods get permissions to do things? How do I give IAM roles to the pods? We're making a lot of improvements in how that works. Removing the OIDC provider limitations and the role duplication issues, allowing you to make that a lot more scalable and easier to manage. And then we're also working on image signature validation, so giving you runtime controls over signature attestation directly from EKS. Scale is also important. Today, EKS scales the control plane dynamically. We don't talk too much about this. I think there was a little bit of talking earlier about this, but we actually automatically adjust all the infrastructure that supports the EKS clusters based on the load that we're seeing on the cluster, and we do that dynamically in real time. So today, we can easily support performance of up to the Kubernetes tested limits of 5,000 nodes, and we're working on what we call mega clusters, which is support for clusters up to 15,000 nodes and 450,000 objects. Okay. Application-ready clusters. What does this mean? What does it mean for a cluster to be application-ready? Well, we think about it as the cluster has everything it needs for you to just go ahead and launch your application. So the first way that we do that is with our EKS Addons product, and that's actually bringing in all the different operational tools that we have to the cluster. So the first thing of that we're bringing is what we call Addons configuration, allowing you to customize how add-ons are installed on the cluster. Addons is live today. It's not very customizable. You just get the thing or you don't. You can change the version. We're going to allow you to customize things like the core DNS core file when it goes onto the cluster so that you can have it set up the way that you need it and have that synced across the cluster. We're going to be adding a bunch more software from AWS into here as well. And then also coming later this year, we're doing an integration with the AWS Marketplace to allow you to get cluster software from third-party vendors in the marketplace and install that software onto your Kubernetes cluster through the Addons APIs. So the vision here is that when you start your EKS cluster, you can say, here's the control plane, here's the data plane, here's all the things I need to run on the cluster, throw the template into EKS, and we'll go ahead and start and keep that all up to date for you. To help you actually template all that out, we have a system called EKS Blueprints. This is an open source framework. You can find this on GitHub. We support the CDK and Terraform today, and it allows you to configure and deploy complete clusters. So the control plane, the data plane, the nodes, we have a bunch of opinionated configurations that we've been sharing publicly here, and you can grab those and you can use these to deploy the whole cluster ready to go very quickly. And it's based on our best practices, it's based on our recommendations, and it's also because it's open source, you can extend it, you can customize it. We called it Blueprints because we see it as a jumping off point in order to define application-ready clusters. You don't have to figure out how to put something like this together, but you can use it as a starting point to go ahead and build out how you want to run your Kubernetes clusters for your organization. Two things we're doing with cost, visibility, and efficiency. First, with visibility. We started this year by giving you the ability, automatically tagging all the nodes that are attached to an EKS cluster in AWS. We automatically add system tags to all those nodes so that you can get full cost visibility across all your EC2 infrastructure. What we were hearing from customers is that they had inconsistent visibility over what was running for their Kubernetes clusters. They would have like a whole AWS account, right? And you would have thousands of EC2 instances or hundreds of instances, and you'd say, okay, some of this is tagged and some of this is not. I'm just seeing all this spend. What's actually part of a Kubernetes cluster and what isn't? So we added system tags. If a node attaches to an EKS cluster for any reason, we throw a system tag on it. You can go into the cost and usage reporting. You can see the name of the cluster, and you can see all the information about that node. So you can get cluster level spend automatically out of the box with AWS. Now, what we're doing inside the cluster is even more interesting. We've partnered with KubeCost to actually offer KubeCost for free to every AWS customer. And so this is not the standard community version of KubeCost. It's the standard plus some paid and business and enterprise features bundled in. There's a custom bundle that we have with them. This is available on Marketplace, and it's going to be available in the new Marketplace add-on integration as well. And this is delivered to all EKS clusters as an add-on, and you can get this for free when you're using EKS and deploy this onto EKS to get fine-grained cost visibility and monitoring for all of your EKS clusters. So really excited about this partnership with KubeCost. We'll see this develop. We'll see it get more native and more integrated over the next year. But this has been awesome for customers who want to get that fine-grained, how much does this pod cost? How much does this namespace cost? How much does this service cost? You can get that data using KubeCost with EKS today. Okay, what about efficiency? Efficiency is a really hard problem. In general, customers tend to over-provision their clusters because they want to ensure availability. So we've been working on this for the last few years. We've recently announced in the last year this project named Carpenter. Now, do you remember I mentioned a while ago, about 10 minutes ago, we launched this project and it sucked and no one used it? That was Carpenter. The first time that we launched this thing, I don't know what we were trying to do, but it just wasn't right and it didn't work. And we sat down and we talked to customers and we actually completely changed the way that this worked from a metrics-based autoscaler to an auto-provisioning system. And so what Carpenter is today is a compute auto-provisioning system. It looks at your cluster and it figures out what does the cluster want to run? What are the workloads that are trying to run? And instead of you having to think up front, hey, I need these instance types, I need this EC2 this big, and I need this group of these, and I have all these different auto-scaling groups, and how do I, like it gets very complicated, right? And then ensuring efficiency when you're pre-setting all your nodes is even more complicated. But with Carpenter, this Carpenter system is looking at the pending pods that are coming off the scheduler, and it's saying, what are the resource requirements of those pending pods? And it's automatically provisioning what the next best instance is for the cluster. So this has been awesome. It allows people to have very rich heterogeneous groups. So you can mix like lots of different instance types, for example, with Spot, which allows you to effectively use AWS tools that can save you significant amounts of money on your cluster. We've also recently announced with 0.17 this workload consolidation feature where Carpenter will look through the cluster and it will see opportunities where you're over-provisioned, and it will terminate nodes and reschedule pods or allow pods to be rescheduled onto new nodes in order to consolidate the cluster down. And that works in a general steady state, but it also works in a downscaling situation so that you don't have to think about downscaling your cluster, which can be a really hard problem to solve. So basically, we're bin packing constantly with Carpenter. Like everything else, this is open source. It's on GitHub. It's a provider model. So right now, AWS EC2 is the main provider for Carpenter, but we built it in an open model. And we've had lots of discussions around the community about other providers that are being built. So if you're a customer of AWS and somebody else, and you really like Carpenter, go and bug that somebody else to build a provider for it. We'd love to have them. What's coming up? Well, node termination handling is something that we're improving right now. So that's when an instance goes away for another reason, like a spot termination. We're also giving customers more settings to kind of improve the instance overrides and different node AMI upgrades. Just like everything else, you can go and check out the roadmap on GitHub. There's also a community working group. We're very excited about this project, and we think that it's gone in a really awesome direction. So come and stop by the booth if you want to check this out and see more about it. But that's our cost efficiency. So if you're on AWS, how do you get access to these capabilities? So first thing we have is this new system called ACK, where we built a bunch of native controllers that allow you to define AWS resources alongside your Kubernetes applications. So if you have an app that needs like an S3 bucket, for example, you can define that S3 bucket alongside your application in your YAML manifest or in your Helm chart. So that allows you to get native AWS resources instead of having to kind of manage those resources yourself. Like if you need a SQL database, you can actually provision an Amazon SQL database instead of trying to run that in the cluster. So a lot of customers have found this really awesome, and we've been partnering with projects like Crossplane to actually have them use ACK as part of their implementations as well. So we've done a lot on this. I won't list all the services. These are the current services that are offered by ACK, and there's a bunch more that are coming out as well. Again, all on GitHub. Search ACK. There's a whole roadmap there. Okay, so in addition to us giving you access to AWS services, there's a bunch of really cool higher level services from AWS that we want to give access to the Kubernetes cluster and let you do things. This is our latest integration. We're just announcing this today. AWS Batch support for Amazon EKS. So with AWS Batch and EKS, you can now do fully managed batch computing and actually run the workloads on Amazon EKS. And this is a multi-cluster aware batch scheduling service, meaning that you can actually connect multiple clusters, multiple EKS computing environments underneath the batch queue and have the queue schedule onto all of those different computing environments. It's workload aware for both scaling and job scheduling, and it's compatible with all existing EKS clusters. So you can use your clusters as they exist today. You can use preferred monitoring and governance tooling like Prometheus. And you can also have Batch will manage that application isolation across different workloads. So if you're running Batch, it can keep your workloads isolated from other things that are running on the cluster. So we're super excited about this. This is the second integration of this type that we've done. The first that we announced last year was Amazon EMR, where you can run managed Spark jobs on EKS clusters, and now we have Batch for running batch computing workloads on EKS. So this is the latest that we have. We're super excited about this integration with the Batch team. They've worked really hard on this for the last year or so here, and you're going to see a lot more of this from AWS, taking higher level services that are existing today that offer really cool capabilities, and then building those service integrations down into Kubernetes so that you can use that service and run the workloads on Kubernetes. All right, we've talked a lot about the cloud, and the cloud is amazing, but we've also done a lot of work to help our customers run outside of the cloud and in lots of different locations. So we have three main products that EKS is offering today. We have EKS in AWS that we've been talking about. We also have Amazon EKS Anywhere, which is a tool chain that allows you to deploy and manage clusters in your own hardware, in your own data centers. And then we have EKS Distro, which is our distribution of Kubernetes that is used by both EKS and EKS Anywhere. And the goal here is that we can help you deploy and operate and secure Kubernetes in any environment, no matter where they're deployed. And that's just the basics. We actually support EKS in all these locations. So we have EKS in the cloud. AWS has these smaller footprint regions that we call local zones and wavelengths. And so from the left to the right, they get smaller and more in the data center oriented. So we have EKS on local zones, we have EKS on wavelength zones. We also support EKS on Outposts, which is AWS managed hardware, which runs in your data center. We also have Amazon EKS Anywhere, which is a tool chain for you to run Kubernetes clusters on your hardware in your data center. And then EKS Distro, which is our distribution of Kubernetes. So what does that look like? In terms of where you can run EKS, in addition to all the places where you might have a data center, these are all the places where Amazon supports managed Kubernetes deployments. So pretty much anywhere around the world, 27 geographic regions, 87 availability zones, 19 local zones, 28 wavelength zones. There's a bunch more even coming. There's a dot that's covering up the 51 new AWS local zones. But suffice to say, our goal that AWS has is that anywhere in the world where you need to deploy Kubernetes, we have a footprint where you can deploy EKS and you can run Kubernetes workloads. Talking about EKS Anywhere, I'm not going to steal Lee Chun's thunder. She'll be up next to go really deep on this and talk about all the amazing things here. But our goal with EKS Anywhere is to support a number of providers and a number of different OS options to support the data centers that you already have with Kubernetes. So GA today, we have support for VMware, for Bare Metal, and Apache Cloud Stack. And we're working on supporting AWS Snowball Edge, which is small form factor devices. A Snowball is about the size of the top of this podium or a little bit smaller and can go anywhere in the world, and we can deploy and run EKS Anywhere on that. We're working on bringing that to GA really soon. And then we're also adding support for Nutanix, which is an infrastructure provider. We have support for Ubuntu, BottleRocket, and Red Hat Enterprise Linux as well. The RHEL support is a newer launch. We just announced that. And there's some really cool stuff that the team is doing here in order to make it possible to bring Kubernetes to any environment in any data center where you want to run it. So recapping here, because we're right at time, centralized and simplified cluster management, application-ready clusters, cost visibility and efficiency, access to AWS, and deployment in any environment. These are all the things that we're doing for our Kubernetes customers. And we've heard about it a little bit someday. We have a few more talks coming up through the rest of the day. I'm really excited to have you here for the second half of Container Day. Thank you very much.